Good morning, HOD Professor A.K. Chaturvedi Sir, my seminar head Rajiv Rajora Sir, my seminar guide Gitesh Vijay Sir, respected faculty members, examiners, and my fellow batchmates. I am Sakshi Vijay, pursuing my bachelor's degree in production and industrial engineering from Rajasthan Technical University, Kota. I am pleased to be here to deliver the presentation on my seminar topic Industry 4.0. What is Industry 4.0? We are in the midst of a significant transformation regarding the way we produce products, thanks to the digitization of manufacturing. The transition is so compelling that it is being called Industry 4.0 to represent the fourth revolution that has occurred in manufacturing. The name is inspired by Germany's Industry 4.0, a government initiative to promote connected manufacturing and a digital convergence between industry, business, and other processes. Why does Industry 4.0 matter? Industry 4.0 touches everything in our daily lives. Industry 4.0 integrates the digital and physical worlds. It's not just about the supply chain or manufacturing, it's about business operations and revenue growth. Stages in development of industrial manufacturing systems from manual work towards Industry 4.0 concept can be presented as a path through the four industrial revolutions. The first industrial revolution occurred between 1760 to 1840 and included going from manual production to the use of steam-powered engines and water as a source of power. The second industrial revolution occurred between 1870 to 1940 and introduced pre-existing systems such as telegraphs and railroads into industries. Perhaps the defining characteristic of that period was the introduction of mass production. Perhaps the third one occurred between 1960 to 2010 and is often referred to as the digital revolution and came about the change from analog and mechanical systems to digital ones. Others call it the information age too. Today, we are in the fourth industrial revolution that was triggered by the development of information and communication, and its technological basis is smart automation of cyber-physical systems and decentralized control and advanced connectivity. Now, let's see the 9 building blocks of Industry 4.0. First, advanced robotics. Autonomous robots can complete given tasks precisely and intelligently within the given time limit and also focus on safety, flexibility, and versatility. Second, additive manufacturing methods will be widely used to produce small batches of customized products that offer construction advantages such as complex, lightweight designs. Third, augmented reality-based systems support a variety of services such as selecting parts in a warehouse and sending repair instructions over mobile devices. Fourth, simulations will be used more extensively in plant operations to leverage real-time data to mirror the physical world in a virtual model. Fifth, physical and vertical system integration. Horizontal integration involves acquiring or merging with competitors, while vertical integration occurs when a firm expands into another production stage, like acquiring a supplier or a distributor. Sixth is the Industrial Internet of Things, which is a system that involves intelligent networking, cyber-physical systems, cloud computing platform that allow access, collection, and evolution of communications, and also enables the industry to exchange data such as process, products and services in real time, thus generating the optimization of production value. Seventh, cloud-based IT platforms serve as technical backbone for the connection and communication of manifold elements of the application center industry. 8 is cyber security and cyber physical system CPS, which is one of the most significant advances in the development of information and communication technologies, is represented by CPS. Last is big data and analytics. According to Forrester's definition, big data consists of 4 dimensions: volume of data, variety of data, velocity of generation of new data, and analysis, value of data. Industry 4.0 Smart Factory. The core process is digital to physical conversion is a reconfigurable manufacturing system. Reconfigurable manufacturing systems are the latest advance in the development of a manufacturing system. First step were fixed production lines with the machines dedicated to the performance of specific tasks, so only one product could be produced. Next step were flexible production systems with programmable machines that allowed production of a variety of different products but offered no flexibility in the production capacity. With Industry 4.0, the 9 pillars of technological advancement will transform production from isolated optimized cells to a fully integrated, automated, and optimized production flow, leading to great efficiencies and changing traditional production relationships among suppliers, producers, and customers, as well as between human and machines. By this example, you can see what smart factory will do. Today's factory, you can see rigidly sequenced car manufacture on a production line, whereas tomorrow's factory is all about decoupled, fully flexible, and highly rigid integrated manufacturing systems. Industry 4.0 has 6 design principles: interoperability, virtualization, decentralization, real-time capability, service orientation, and modularity. Current state of Industry 4.0 in India. India has to move from manufacturing outfits of Industry 1.0 and 2.0 to Industry 4.0 and beyond. As of now, the automobile industry in India is the only industry that has shown good promise in terms of factory automation. The number of installed robots in the automobile industry is 58 for every 10,000 workers. Though still a modest figure, it is nearly 19 times more than the nation average of just 3. The concept of Industry 4.0 is going to change the way India manufactures, designs, and refurbishes the products. Now let's see how India will benefit from Industry 4.0. First, it will allow manufacturers to improve productivity, efficiency, and safety. Second, small and medium enterprises, which will form the backbone of Indian manufacturing, can leverage Industry 4.0 technologies to become more agile, enhance productivity, streamline costs, and reduce risks. Third, employers will be able to increase the skills of the workforce. While some jobs may be lost, new ones will be created in the new economy. Finally, Industry 4.0 could provide a pathway for Indian manufacturing to transform to an innovation-led and high-value manufacturing state. Industry 4.0 isn't something that relates only to the manufacturing sector. You might say we will soon be living in an Industry 4.0 world, and using Industry 4.0 technologies in various sectors will be the outcome. For example, agriculture 4.0, quality 4.0, supply chain 4.0, retail 4.0, healthcare 4.0, pharma 4.0, and energy 4.0. Now let's see the benefits of Industry 4.0. Increase of productivity, remaining competitive, increased knowledge sharing, cost effectiveness, flexibility and agility, better customer experience, and many others. Industry 4.0 limitations can be stated as a gap in technical skills, data sensitivity, interoperability, security issues, handling data growth, etc. Lastly, briefing out the applications of Industry 4.0. Workplace safety, product monitoring, supply chain management, quality control, asset utilizations, and many others. You may have a look at the references, and that's all from my side. And now I wish to resolve your queries, if any.
How can an organization succeed in Industry 4.0?
Well, that's a great question. Thank you. Well, no matter what the technological advancement, I believe companies should follow a new basic rules. Focus on the target customer and outcome and build organization plan based on those. Establish a schedule, roadmap, minimum viable organization and clear message. Ensure that the employees understand organization's overall vision and actively participate in its development. And last, product valuable training, adequate time and budget to deliver on one's vision and objective.
How much does it cost to implement an Industry 4.0 solution?
Costs depend on variety of factors, including the number of machines to connect, the addition of hardware, components to enable connectivity, the price of associated software licensing, and the level of individualization of the software. So pick what is important to you. Any other?
No.
Thank you.